Hello, everyone. Thanks for joining our webinar. I'll have a few more people trickle in before we actually start. Danny, can you please go to the introductory slide, which has the title? Yeah. Thank you so much. And so this webinar is called Building Real-Time Data Pipelines with Estuary and SingleStore. So thanks everyone for joining. This is a partner webinar that we are hosting. I am Yukti. I'm from the growth engineering team at SingleStore. And one of my main jobs here is to take care of these webinars and host them. So we are very happy that you all have joined. We have an amazing panel of experts that have joined us today. We have Esteban, who is the CTO of Recart. We have Luca from SingleStore's side, who is an expert at the platform and is going to take care of all your questions if you have any. We also have Danny from Estuary, and he's also an expert. I will be sharing the resources to everything that you need to follow real time in the chat. So keep an eye out. Just an FYI that you are currently in a listen only mode, and you can utilize the Zoom Q&A button in case of any questions. We will try our best to take care of it. We also have Spandana and Chetan from the product team that will take care of any questions that I think Spandana is related to the Mongo Kai variant of this webinar. So she can take care of that if you have any questions. And I hope to see you all engaged during the session. So please feel free. We have I think I'll hand the mic over to Danny that can take it away, or maybe Luca, whoever's okay.
Yeah, I'll start.
Yeah,
thank you.
Please start. Okay. Thanks everyone for joining.
Thank you.
Okay.
Thank you. Hi everyone. So I think thank you for the introductions. Briefly for the agenda, what we'll cover today is I'll start by giving a quick overview of SingleStore, what makes it unique and purpose-built for real-time analytics and AI. Then we'll have Denny from Estuary deep dive into how Estuary, the product, enables a seamless real-time data movement between various data sources. And also he'll be doing a live demo. And then finally, we'll have Istvan, who is one of our joint customers, a CTO from Recart, who will be talking about his kind of real-world perspective on how their team uses both SingleStore and Estuary in some of their use cases. Please, if we go to the next slide, a quick introduction on SingleStore. We began in 2011. Back then we were called MemSQL, and we started as a kind of high-performance in-memory OLTP database. Over the years, we've evolved, added numerous features, and so we can say that today we can handle transactions, analytics, search, and AI workloads all in a single engine. So hence the name SingleStore, which we were kind of rebranded into in 2020. We've had several fundraising rounds over the years. You can also see some of our investors here. And then I think globally we cover more than 400 customers. And we deliver everything from like mission critical applications to financial trading dashboards, LLM-based AI assistants, real-time personalization systems. So a lot of different use cases. If we go over the architecture, I think what sets SingleStore apart is our unified engine or universal storage, where you don't need separate systems for handling transactions, for handling analytics, or for handling search. Instead, everything happens on a single platform. And so this uses the combination of in-memory row store and then compressed disk-based column store. So this is quite unique. And apart from that, we also support like the things that you would expect for a real-time data platform, such as high throughput of data through our distributed ingest pipelines. And I think we'll go through that in a moment. We also support various query engines. We're like multimodal. So you can run SQL queries in kind of relational fashion on SingleStore. You can do joins, aggregations. You can work over JSON data as well, so semi-structured. We have support for time series, geospatial, and then vectors as well. You can also extend SingleStore through procedural logic, which is either implemented as stored procedures or UDFs, user-defined functions. And here you can also use WASM code in C, C++, or Rust to really create high-performance extensions to your solutions. We have a SQL and Python-based notebook support as well. And this is for developers, analysts, data scientists who want to run their models and interact through the platform that way. So all of this is horizontally scalable. So SingleStore is a distributed database. We use a shared nothing architecture. We have sharding and partition pruning. And our architecture is basically lock-free, designed for massive parallelism. So this gives you, low latency for reads and writes, even under heavy load. And yeah, so usually we're best suited for modern applications that demand real-time, decision-making, such as fraud detection, for example, or operational dashboards. So if you go next, we can take a look at our architecture. So here you can see that we can be like on the bottom layer here, you can see that we're deployed either as the managed service on one of the three clouds, AWS, Azure, and GCP. You can also self-manage a SingleStore as an on-prem deployment through Kubernetes or VMs or even bare metal. And there's a BYOC option as well, so bring your own cloud. We have a Snowflake partnership where you can be deployed as inside a Snowpark container as well. So as I mentioned, we're a horizontally scalable database. So with SingleStore, you have data nodes or leaf nodes, which actually hold the data and process the queries. And then you have nodes, which we call aggregator nodes, which do the routing and communication with the clients and the users. And so as a developer, you either talk to us through a SQL endpoint. We are MySQL wire compatible. And so a lot of tools will just work out of the box, like reporting tools, various SDKs, JDBC drivers, etc. But we also have a Mongo endpoint, which is interesting if you want to unlock analytics over semi-structured data. Obviously, for all of this to work, you first need to bring data into the database. And so, we all know that today batch ETL pipelines are not sufficient. Modern applications want data to flow seamlessly between operational systems or systems of record into analytical systems. And so SingleStore has this capability, which we call pipelines or zero ETL pipelines, and we can dive deeper into what they are. So here on the slide, you can see centrally like all of the different data sources that are supported through this pipeline feature. So systems like Kafka, various object storages like GCS, ADLS, S3, etc. But we also support native integration with Mongo and MySQL, which is interesting for bringing CDC data in. Some of the key features of pipelines, which I think are really interesting, are support for various data formats. So obviously JSON, AVRO, Parquet, and lately we've also added Iceberg as a format as well. We have exactly one semantics and transactional consistency. Again, important for bringing data from these systems in order and without duplication. And then for scalability and kind of deployment or usage at scale, we have parallelization across our partitions and nodes. So this would be our leaf or data nodes, where we can load data from the sources in parallel fashion. If you want to do any like transformation or enrichment, we do support this through the usage of stored procedures. But obviously, like to extend this even more or to support more data sources, like SaaS applications, databases, anything that's not here on the list, we partner with tools like Estuary, right? So Estuary, I think, is a great tool to abstract the various complexities of streaming and CDC pipelines, and so you can bring data from almost any source into SingleStore through Estuary. So I think with that I'll hand over to Denny to walk us through Estuary.
Awesome. Thank you so much, Luca. And nice to meet you, everyone. My name is Denny. I do marketing and data engineering and a bunch of other things at Estuary, but I've been working in data for over a decade now. I used to work as a data engineer for most of it as a consultant. So I've been in startups, large enterprises, pretty much all around. So the goal for me with this presentation and the demo after is to try to show you how real-time pipelines and real-time analytics is as accessible that it has been ever. And there's no real reason to just stick with batch anymore just because it is easier or cheaper. So I think most people understand the value that real-time analytics can provide, but still think that the cost outweigh the benefits. So So just to give a little bit of context, real-time is everywhere, and it has many tangible benefits. Every application that we interact with in our daily lives essentially expects real-time actions. So whenever a human is involved in the loop, we almost always want immediate gratification. So it's super valuable to have lower latency reporting, so you don't have to wait for insights at all. So in this word, or in a word, we have a reporting layer and a monitoring layer, and the only real difference between the two is latency, and that's not out of desire. It's only because of necessity, or at least has been so far. So at Estuary, we see real-time use cases in pretty much every industry that you can think of, from healthcare to fintech, or from marketing to logistics. We find that whenever real-time data actually becomes available for a company, industries find ways to improve in many ways, like internal efficiency, customer experiences, and any kinds of business outcomes. You can see a bunch of examples of real-life use cases of real-time analytics or real-time data pipelines on this slide, but yeah, there's many more, like the one that we are going to dive a bit deeper into at the end of this presentation with Recart. So real-time data and streaming data is not really just about low latency. There's a lot of value to it, even if you want to use your data every few hours, for example. So let's talk a little bit more about those. One good example is CDC, or change data capture. That is an area that has major advantages when streaming data is employed. So just a very technical example is that a Postgres database requires processes that read the log to acknowledge when they actually are finished reading, so the database can delete segments. And if you can do this quickly, you can prevent a lot of operational issues around disk usage and wall segments, which can usually happen at the worst possible times and can cause a lot of headache. So it makes sense to consider these types of things before you decide if you want a batch pipeline or a streaming pipeline. And just defaulting to streaming gets rid of a number of these issues. Some other benefits include incremental replication by default, lower impact on your source databases, and enabling cool stuff like many-to-many replication as well. So when I talk about streaming and real-time, almost immediately everybody thinks of Kafka. But yeah, so real-time is Kafka, and Kafka is hard, right? So Kafka is the pretty much default answer to real-time data infrastructures. And I think it's used in like 80% of Fortune 500, or probably more close to 100% nowadays, who knows? And they use it for messaging, logs, and all kinds of event-driven applications. But Kafka comes with a whole host of its own issues. So it's complex to set up, even for like super small applications, and it requires a lot of maintenance overhead to keep those clusters running. I'm sure some of you have experience with Kafka, especially coming from a real-time data environment. So you probably understand that sometimes it can feel like just another obstacle instead of an actual solution. So to dive a little bit more into real-time problems, I try to categorize them as much as I could, but there's a lot. The biggest one probably is operational or infrastructure complexity. So most organizations, in my experience, find themselves maintaining a lot of connectors, message queues, and transformation jobs as well. And this can get out of hand very quickly. Something that starts as a super simple pipeline becomes very hard to maintain over time. The other one being operational overhead. I think it's not really a secret that data pipelines require, or a lot of teams spend insane amount of time monitoring, debugging, and fixing data pipelines, as opposed to actually extracting value from the data that they transport. I've seen teams dedicated to just keeping pipelines alive, where they could have been doing something with the data those pipelines are moving around. The other one that I usually like to emphasize is the variability in data volume. And this is important to consider because sometimes your pipeline just moves like 100 events per second, and the next second it has to move 100,000. And traditional solutions are usually either over-provision resources, which wastes a lot of money, or under-provision resources, which risks failure at probably the most critical moments. And transitioning between the two usually is very costly. And not on this slide, but I usually like to mention schema evolution as well as a runner-up, because as most of you already know, the source systems that provide data for you never stay static. So fields get added, formats change, and before you know it, you're stuck running DDLs in your destination and backfilling pipelines from the beginning of time just to get everything back from where you actually started. So as you transition into real-time data usage and pipelines, it's very easy to get into a situation where some of your data pipelines are still batch-based. Even in mature data architectures, some data remains batch indefinitely, and that's totally fine. Or in some cases, you just want a different sync schedule for different parts of your data. It is important to keep in mind that joins across all of these data sources are only as fast as your slowest pipeline, which very often can reduce value for the whole stack. So there was a lot of complaining. Sorry about that. It's something that I like to do nowadays, but it's time for solutions. So how can we actually implement real-time pipelines and real-time analytics without all of this hassle? Estuary's answer is Decaf, because Kafka is everywhere, but the value is not necessarily in Kafka itself anymore. Rather, it's the protocol, the Kafka protocol, that enables communication between disparate systems. So most databases and warehouses already know how to speak Kafka. So just tapping into that ecosystem already is extremely valuable. The way Estuary taps into this ecosystem is through Decaf, our native Kafka-compatible layer. So this enables any system, essentially, that understands the Kafka protocol, such as a SingleStore, to subscribe to real-time data without the need for you to actually run Kafka. Since Kafka is notoriously difficult to manage, as we established earlier, Decaf makes it possible to get the value out of Kafka without any of the complexity. So no brokers, scaling, or partitioning, or any kind of maintenance. All of that is automated and packaged into the service. So setting up this whole thing is super simple. I'll show you an example in a second in the demo. But all you have to do is just set up your credentials and some super minimal configuration, and Decaf enables you to get real-time data that you can plug into a myriad of services that are Kafka compatible. So now we get to the part where I actually talk a little bit about Estuary, the platform itself. So beyond Decaf, Estuary is a real-time data integration platform that bridges the gap between batch data and streaming data. Our aim is to make it as easy as possible to move data in and out of systems using declarative pipelines, whether you're working with databases like legacy databases or APIs or file stores or even modern event streams. So Decaf is a compatibility layer, as I mentioned, that makes it easy to integrate with a broad ecosystem. But Estuary also has like direct integrations with hundreds of other sources or hundreds of other data systems that use some kind of custom methodology to actually drive or actually connect to them. We are able to plug into AI vector stores, data warehouses on the destination side, but on the source side, we support stuff like NetSuite, Salesforce, Stripe. So all your enterprise data can be extracted in real time and piped and joined together with other data sources. So this enables your data essentially how you want it, scheduled or speedy with connectors to the systems you use, all at a very predictable and transparent cost. The platform supports a fully automated schema evolution, and we are also be able to deploy it in private network environments or even in a BYOC fashion on the hardware that you provide us. And with that, SingleStore and Estuary is kind of a perfect match, as SingleStore adds the power to that real-time data streaming or stream, enabling fully automated real-time analytics, like end-to-end real-time analytics at any scale that really is as simple as working with batch pipelines. So if you want to try it out for yourself, it's completely free to get started. I think Yukti will share the registration page with you. And if you want, you can even follow along with this demo or maybe do it yourself after. All the code that I will show you will be available in a public GitHub repository. So if I am correct, I might have to share the other screen. So give me just 1 second. Actually, I'll just share my whole thing. So can someone let me know if you see Estuary, the Estuary dashboard now?
Yeah, we can see.
Awesome, cool. So yeah, just for the sake of this demonstration, I am going to show you a data flow that extracts data from a Postgres database and moves it all the way into SingleStore in real time. To show that we are in fact generating data in real time, I have this script running here that is constantly inserting data into one table, sometimes updating records and sometimes even deleting them, just so we can demonstrate change data capture functionality as well. So this database is already running. And the first step is to create a connector on the Estuary side to actually capture the data from its write-ahead log. So if I wanted to do this all from scratch, I would navigate into the sources menu and create a new capture here. And this is a good way to showcase all the hundreds of integrations that we currently support. As you can see, it's a huge list of databases and SaaS tools. Most of the operational databases are here. You can even extract data from Snowflake in real time using our connector, but we support stuff like Salesforce or NetSuite as well. And yeah, you can take a look at it yourself. If it's not here, we can develop connectors fairly quickly nowadays as well. Yeah, as for this demonstration, I was talking about the Postgres database, and I already have the connector for it up and running here. So I'll just open that up and show you how it looks like. You can see that we have some high-level statistics of the data or the amount of data being captured by the connector, and some general information about its health. Just to show you how easy it is to actually configure something like this, I'll go into the edit page. And here in the endpoint configuration, all you have to do is specify your connection details to the database, and then you select whatever tables you want to replicate using Estuary. And as a last step, you can configure schema evolution as well. As I mentioned, we support fully automated schema evolution but you can tone it back in case you want your pipelines to fail on a breaking change because you want to handle it yourself. So once a connector like this is up and running, you just after you press save and publish, it takes like a minute. Once it's up and running, it starts capturing data in real time and saves it into collections. So it's not a point-to-point replication like other systems, because we have this data lake in the middle, which serves as an intermediate storage. So as you can see here in this table, this connector writes to this orders collection. These collections are JSON documents on an object storage that the user actually provides the platform. So it's a bring your own storage type of deal. So we don't store any data, and the user has full control over this intermediate storage. They can set whatever retention period they want or utilize their existing cloud credits. So if you look at the collection itself, we get some similar statistics, and we get a peek into how the data looks like. So if you ever worked with change data capture, you can see, or you'll know that this operation means that this record represents an update to a row. But if I click on another one, another one, this one has a C as its operation type, which means that it was a create operation. So we are capturing all updates, inserts, and deletes as separate change events, which allows us to reconstruct the history for analytics as we want it. So this, as I mentioned, happens completely in real time by the capture connector, all the data being saved into this collection. And as a last step, you create a materialization connector in Estuary, which is responsible for pushing the data into a destination. Now, this can be a data warehouse or another database, another operational database, or in SingleStore's case, it's a little bit special because, as I mentioned, it's through Decaf, our Kafka compatibility layer, and which means that we are not pushing the data into SingleStore, but SingleStore is reading the data from these collections. So with Decaf, we create a Kafka API that is accessible by anyone. And Decaf, or a SingleStore, using its Kafka source, is able to read data from our collections as if they were Kafka topics. And I'll show how to set that up in just a second. So the connector setup itself is super simple. I'll go into the edit page again to show you. But essentially the only configuration that you have to do is just creating a token to manage the authentication from the consumer side. And you have to select which collections you want to expose through this connector. So here I added this orders collection that I showed you earlier that contains this changelog of these orders table. But just to showcase, I added another collection here. So this way you have an idea of how you only need like one of these connectors to load data into SingleStore from potentially dozens of data sources. So once this connector is provisioned and up and running, which it already is, as you can see, I have this connector up and running here, and it has some data going through it already. I can jump into the SingleStore side in my other Chrome tab and show you how you can set up or how you can ingest this data in just a few seconds. So I have a notebook here that is a good way to actually share this. I'll try to export this and also send it as a follow-up as well. So here, as I mentioned, Decaf is a Kafka API compatibility layer. So all the configuration is exactly as if you were connecting to a Kafka broker. I set up all the authentication details, the schema registry, all the records that Decaf provides are in AVRO format, but we have a schema registry that we provide as well. So we just have to configure the connection details. Next up, I create a orders table with some of the fields that I want to ingest into SingleStore. And as the last step, I create the actual pipeline that will be responsible for moving the data from this Decaf broker into SingleStore. And here you can see that I set the format as AVRO using the schemas from the provided schema registry. So this pipeline is already running. I already started it a few minutes ago. And just to verify, I will run this name or service unknown. Sorry, I think my connection was suspended. That's bad timing. Anyway, I can still show you how it looks like. So I run this query, selecting the first few records from the table, and these you can see in this result table that these are indeed the actual values that we are extracting from the collection from Estuary. And once this database connection is back up and running, I might be able to show you that it's actually in real time, but resuming it might take a bit more time. So I think the pipeline itself is still in running state. I can show you that here. And it has a bunch of batches already ingested. And yeah, I can take a look at quickly the Grafana dashboard as well. And there's a bunch of stuff here, but here in the middle, you can see that data is actually being streamed from this orders demo database, or into this orders demo database using this pipeline. And essentially that's it. Like to set up this whole end-to-end. And now after this pipeline is up and running, all the data is available for you in SingleStore. So yeah, it's like 5 minutes on the Estuary side, 5 minutes on the SingleStore side, and you have a fully end-to-end, completely automated real-time analytics pipeline. So with that said, this is a very simple demo of how to set up things, but luckily we have a guest here, István, who is who works at Recart, who's a customer of both SingleStore and Estuary, and he can say a few words about how they use both of these platforms and what kind of cool things it enable for them at Recart. So with that, István, I would like to pass you the mic, and yeah, if you could say a few words about how you use Estuary and Recart, or Estuary and SingleStore, sorry.
Thank you. Hi, folks. Just a few words about Recart. We are creating a marketing platform for SMBs all around the world, but most of our customers happen to be in the US or in Canada. Basically, when we started to look around more performance solution for our data stack, the use case that we wanted to implement was our segmentation engine. And the segmentation engine, as its name suggests, is used to set up segments to be used for targeting for marketing campaigns. And it has to be exceptionally low latency, or it has to have exceptionally low latency, by which I mean 100 milliseconds of latency, maybe 500 milliseconds of latency for every change, because the system is near real time, and most of the things that happen in our system is basically based on events. We actually found Estuary in the process, and SingleStore as well, as you can see. How we use the two tools together right now. We started to play around with Estuary, and the first use case that we started to use is basically we moved data from one of our DynamoDB tables to a Postgres instance, basically for our business intelligence or reporting use cases. We learned how to use the tool. We learned what we actually do not know about the tool. And then we started to play around with the segmentation use case. And the segmentation use case is basically about replicating with MongoDB change streams data from 6, maybe 8 MongoDB collections, transforming these. So at the end of the day, when all these data is arriving into SingleStore, it has to be about or around 10 to 12 tables, basically, because many things are stored in arrays in MongoDB, and those needs to be flattened out into dedicated tables. And basically, using the distributed nature of SingleStore, we were able to decrease the latency of some complicated segment definition, at least the calculation of these use cases, from tens of minutes, sometimes 30 minutes actually, to a few hundred milliseconds. In the worst case, it would be around 2 seconds. So, tens of minutes to 2 seconds in the worst case, a few hundred milliseconds in the usual case, which is an extreme change in our platform. Why we needed this change in the platform? Basically, we have a couple of customers who became exceptionally successful, I would say. They found their ICP, they were able to build their business in a very meaningful way, and they were able to grow their audiences throughout Recart. And basically, when MongoDB needs to handle very difficult aggregations with a huge amount of conditions, some conditions are not really, MongoDB is not able to support all these kind of conditions basically throughout indexes. And those indexes that we cannot manage, those queries that we cannot manage with indexes or through indexes, will be extremely slow. And that was, the tipping point in our decision-making process. Okay, to look for other tools, it's going to be a replication problem. Look for something that can be done in real time. Look for something that can be queried in almost instantaneously. And this is when we find the two tools. On the other hand, the plan is basically to move most of our data stack to SingleStore. So right now we use RDS from AWS for business reporting. The plan is to move this as well to SingleStore, and hopefully all the analytical stuff and all the transactional stuff is going to be stored in SingleStore at the end as well.
Awesome. I definitely have a few follow-up questions, but I'm pretty sure Luca also has some from the SingleStore side. And which one of us should go first?
You can go ahead, Denny, then I can add my question too.
All right, cool. Yeah, so I think my first question is when you were evaluating options to sync data into RDS and SingleStore as well. I'm curious if you looked at alternatives like Airbyte or even Kafka, as I talked about it earlier, and what was your thinking process during this?
Absolutely. As the CTO, of a company, I'm an engineer at heart, and I try to really understand all the details possible. And the main problem they wanted to solve is basically low latency and near real-time data replication. I would say that there are some tools that can make it happen, but on the other hand, we needed to be cost conscious as well, and we needed to make sure that it's reliable in many other ways and when we actually started to build out reporting in Recart, we started to play around with Airbyte. We used Airbyte for some time, I would say for 2 years or so. Then they changed their billing setup. It became exceptionally expensive for our use case. We moved to another tool. This tool was mostly for batch-based replications. And it turned out that replication, not just for the segmentation engine, but also for the business, should be done through CDC pipelines or to be real time. Because for companies like us, Black Friday and Cyber Monday are the most important part of the year. Everyone wants to see all the details right after all the events have happened. And this cannot be done through a tool that can only, replicate data in batches. We need to see the data at least in 30 minutes or so. And that's why we actually choose Estuary. So 2 reasons. First, it makes data replication happening near real time, a few hundred millisecond stops. Also, how it's priced is very user-friendly, I would say. So these are the 2 main points that we use to evaluate the tools. And basically, There is 5 trend. If you are an enterprise, if you have all the money, go for it. There are other tools as well. If you would like to have something that can help you in this endeavor with reasonable price, good support, I would actually choose Estuary again.
Awesome. That sounds amazing. Thank you. And I'm curious about how Estuary helps you manage both real-time and historical data needs, like backfilling larger batches of data from object storage or anything like that.
It actually turned out a really good thing to have, let's say, a data lake behind Estuary. We use actually AWS, so we have our own S3 bucket to store all the data. And basically how we manage data and how I actually manage data is to move from the sources to this bucket and synchronizes from the bucket of near real time to the destinations. And basically, as we were playing around with Estuary and learning about how things should be done, we needed to resync all the data many times because we made mistakes. And this capability helped us to not put pressure on the transactional systems, which is kind of cool thing because, we made mistakes. Even with terabytes of data, sometimes we messed things up and we needed to replicate all the data. So it helped us a lot actually and made things, I would say, reliable for the product that we build.
Awesome. Thank you so much. I have one more question before passing it over to Luca. I'm just curious about the experience of setting up the integration between Estuary and SingleStore. How did that process look like? What was what were your impressions?
I would say it was an easy one, to be honest. We leverage Decaf. SingleStore has a Kafka support, so it was an easy thing to do. There was basically one thing that we needed to learn, and that's the difference between how MongoDB stores the time values and how the MySQL compatible SingleStore does it. We actually only store UTC data, and it turned out we needed some kind of transformation to make sure that the format in MongoDB can be properly handled with all the tools because, time zone management sometimes can be a hard problem, I would say, how it's represented, how it's handled, when you add it, when you remove it. So yeah. But basically we spent a morning with Luca and his team and everything started to work. It was a really nice experience, I would say.
Awesome. Cool. Thank you so much. Well, that was everything from my side. So I would love to pass it over to Luca for your questions.
Thank you.
And should I leave this slide on the screen, or is it okay if I close?
I think you can leave maybe just for like context,
okay.
if it's fine. Yeah,
sure,
just for folks to when they're looking at the screen and the use case. So Istvan, maybe a question from my side is around SingleStore with its kind of MongoDB compatibility, and also Estuary as a kind of has a host of these different connectors. So how did this help you minimize the kind of integration and all of your code changes? Because ultimately it is kind of at least perceived as a big change, right, to introduce these kind of systems.
Yes, I think the assumption that it's going to be a big change for everyone is correct. On the other hand, it can be implemented in a very easy way, I would say. The MongoDB compatible interface from SingleStore makes things relatively easy. We did not have too much hassle around it. There are some use cases, if you are like Recart, that you support many kinds of use cases from the same table or from the same structure. Sometimes you need to find things out and you need to talk to people from SingleStore. But basically, the use case that we first tested SingleStore with was done in 4 hours, I guess, which is super simple, to be honest. So we basically added a new connection string to the microservice that we built, run the very same query that we ran against MongoDB, and it just worked out. On the other hand, if you have many complex use cases, I would say that those are not going to be as easy as it was. But yeah, it's, you know, how to phrase it, how I should say it. The learning curve is very developer friendly. This is how I would phrase it, actually.
Yeah, that makes sense. And I remember when we were together, it was quite fast to iterate as well over these use cases. So that brings me to my next question. When you say you saw like query latency drop from tens of minutes to seconds or milliseconds for specific queries, obviously there's a benefit for your customers, for your end users, right? Just the speed of insights and everything else. But I'm wondering for like your developers and for your workflows internally, productivity or just for releasing features, how does this help you iterate?
The idea that we plan to implement is basically move all the business intelligence related stuff into SingleStore as well. We actually played around with it. We had a Postgres instance on RDS in AWS. The query time is decreasing into a level where you can feel a real-time understanding of problems or getting real-time answers to questions. And basically, if you need to do a product-related decision, which thing to implement, how it's going to have an effect on our ROI, how it's going to have an effect on the revenue of the company, it can be done almost instantaneously. So yeah, it can help us to make decisions a lot faster. Yeah, this is basically it.
Makes sense. Makes sense. Thank you. Maybe one last question, I think, from the Q&A here. One of the people on the webinar asked, how did Recart utilize SingleStore in the overall process? And what was the role of Kafka and Decaf in this use case?
Basically, Decaf and Kafka was used and is used for data replication. And we did the transformation in Estuary as well. And we used SingleStore for querying the data. When we use SingleStore for querying the data. There are many other options as well. So we started to look around how things can be optimized in a better way, how JSON or semi-structured data can be or can have the best performance in SingleStore. We needed to learn, all the details around the database or about the database. And it turned out that with absolute minimal changes to the schema, we can speed things up immensely. By which I mean that from a query that runs, let's say, for a second, it can be decreased to a few milliseconds, which, if you are just thinking about the time that you as a developer wait to run the query, it's insignificant. But if you think about how much more queries you can run if you can reduce the latency from, 2 seconds to 200 milliseconds, it's insanely helpful in use cases like Black Friday, Cyber Monday, when everyone is looking at analytical data, how my campaign is performing, how the messages are sent, how things are looking, what should I do, what should I do next? For these use cases, it's immensely helpful, really.
Great, thank you. I think these are all the questions I had, Denny as well. There is one outstanding question in the Q&A. I think, Spandana, were you going to answer this one, or if not, I think...
Oh, no, I have a question. So I just want
okay,
to understand that you are making great use of SingleStore's capabilities for its fast analytics. So what's your roadmap like? What are the different databases you're really planning to have in the tech stack going forward, now that you have seen the power of all the databases?
That's a good question. The plan is to basically have the least amount of tools that we can have. And I think in that regard, SingleStore could be a really good app tool for Recart, as the hybrid setup of transactional analytical processing can be done easily in SingleStore. I see it as basically handling most of the data or almost all the data of Recart. The migration, until the migration process is going to happen, MongoDB is going to be part of this stack. Hopefully, we will be able to move away from the RDS as well, and actually having better performance on SingleStore. So this is the idea, basically, to have only one tool, which can be, leveraged through MongoDB query language and through SQL as well. MongoDB is a good tool in many regards, but the use cases that we outgrow the analytical part of MongoDB, and I think SingleStore is going to help us a lot in the future.
Thank you. I think with that, we can probably wrap up. Yukti, yeah, over to you.
So thanks everyone for joining. Just an FYI, this session was recorded, and I will make sure that in case anyone missed or joined late, this webinar will be emailed to all of you. So from SingleStore's website, I'll make sure of that. And any resources that were there, Danny, is that okay if I include it as well in the follow-up email? So
Yeah, of course.
just for everyone that is there, we are actually doing an event. It's called the Upsert product launch. It's a SingleStore 9.1 version. I think Luca might be aware of it, and others as well. We will have the landing page for that up and running very soon, and you might see that as well in the follow-up email. So feel free to check that out. Once again, Danny, Luca, Istvan, thank you so much for joining. Thanks, Chetan and Spanna from SingleStore to also to join. And if you have any other questions, any feedback, any suggestions that you might have for future webinars, please feel free to connect with me on LinkedIn and drop in a message to or at team@singlestore.com. If there's anything else, please feel free to reach out. And thanks everyone for joining, and your time is really valuable to us. And yeah, that's it from our side. Is there anything else that you guys want to cover, in case I missed anything?
No, I think we're good. Thank you.
All right. Okay. So thanks everyone for joining. Have a great rest of the day. Thank you. Bye.
Thank you.
Bye-bye.
Bye-bye.
Cheers.